Okay, our project is titled Detection and Mitigation of UID Impersonation in IoT Devices using the Kalay protocol, and it was developed by myself, Nicolas, and by my teammate Yaseer Sabir. Currently, millions of users worldwide use the Internet of Things to remotely control devices and monitor their homes, offices, businesses, schools, or any other location. Currently, ThruTake is a company that provides online services such as the Kalay network in this case to a lot of IoT device manufacturers that allows them to help connect the users to their respective IoT devices. A critical vulnerability affecting millions of IoT devices was disclosed in 2021 for all devices that rely on the Kalay network for transmission. Essentially, the attacker can impersonate IoT devices by using the device's UID number and then later use that number to redirect footage from a victim's IoT device to the attacker's control device through the Kalay network. Currently, the Kalay network's connection process works like this. The user's smart camera or home network, when it first gets activated or registered, sends a registration request to the Kalay network using its unique device number or UUID. Once the camera is registered on the Kalay network, the user can request to view the camera footage through their mobile app. Okay? Then the Kalay network will send an additional request back to the camera and then initiates a collection to the client. And then the client can receive audio or video data from the smart camera as part of their home network. However, if an attacker manages to spoof the victim's device, essentially its UUID, it can send a registration request to the Kalay network with the attacker currently as the owner. So when the user requests to view the camera footage to the mobile app, ThruTake will direct a reply instead of to the user or to the attacker, which will provide the attacker with the device's credentials. The attacker can then use those same credentials to send a video or audio request to the IoT device impersonating the user. And the IoT device will then, in response, redirect the audio or video flow from the camera to the attacker's device, enabling the attacker now to essentially spy on the person, on the victim, violating their privacy and take control of their smart camera. Now, Yaseer will continue to explain our methods and how our patches work. Thank you.
Hello, this is going to be our demo for our Kalay UID impersonation and defenses. So just to show the baseline emulator, how that it is in fact impersonating a valid user. So I have my emulator opened up over here in my clients. The emulator is, if I open up the UID.json, as you can see, it's empty right now. So we'll see what happens once I register the user. So I'm going to start our Flask server first. Flask server, which is our emulator. Now I'm going to start our Flask server, which is our emulator. It's running. Next, I'm going to do a valid user registration. So a user here, it's going to be Alice, is going to register. And as you can see, that's getting logged. I'm getting an OK message saying owner is equals Alice. Now, if I reload this, right, as you can see, it is my UID.json is logging Alice with the timestamp of when she was last seen and the IP address from which she logged in. Now, how does what would an attacker do? An attacker how would they want to UID impersonate, right? So what would happen is I'm going to first cd into our folder, cd attacks, and run our re-register from that attack. So this is the attacker script that he or she's going to run. If I run that, as you can see, the attacker script had the credentials and the UID of Alice, right? As you can see, now the owner is equals to evil. Now, if I reload our UIDs.json, as you can see, we have the evil person as the owner, last seen, and the IP address. You can see this is being logged. We are logging this, and we will build defenses upon this, like credential hardening, in the next couple of clips. Thank you. Next part of this demo, instead of using a global hard-coded password, it's going to be user-specific. And in this case, it's going to be Alice's specific password, not a global hard-coded one. So let's, the Flask server, our Flask emulator is running. Going to run our device client, which is going to register Alice with her unique password. So Python 3, as you can see, that's logged. She's able to create her user. In the UI, and let's see if it's reflected in our UID.json. Yes, it's reflected with her password also, if you can see this time. Now let's do it, let's try doing re-register. This will fail because the attacker doesn't have the correct password. But what if the attacker is somehow able to get this password of Alice's? Let's go to our attacker script and write down and put in Alice's password. Alice's exact password. Somehow he's able to get Alice's password. Try re-registering now. As you can see, it did succeed. Now the next part of the demo would be to see what else could we add in terms of credential hardening and securing Alice's password. All right, now we're adding another layer of hardening. Let's start our emulator. So starting that, okay, our emulator is started on our server. Next would be for Alice to register her device, see if that goes through. Then it does go through. Now let's look at our UID.json file and how that, what that is showing us. And as you can see, the UID.json file has been updated now with the hash of the password. So the password it cannot be seen, right? And first, let's say the attacker somehow knows the password. This is the SHA-256 algorithm that we are using here to hash this password. Let's say they don't know it. They're not gonna be able to register, right? And that owner is still gonna be Alice. But now let's say they somehow know the password. In this case, Alice password. Okay, now and they register again using Alice's known password. As you can see, the owner is now the evil attacker. Next steps would be to see how we could make this defense stronger. Now, one small step before we actually move on to the further high-level defenses, right, is making sure we're making this as mimicking as much mimicking the Kalay UID protocol as much as possible. Okay, so to do that, I've made a small tweaks. Number one is that instead of manually like logging like okay, this user entered from this IP, I'm gonna add a layer of monitoring like that actively runs while a valid user like Alice registers or an attacker tries to compromise the UID. So how would this look? So let's run the UID. Let's run the emulator. So emulator is running. Now, the tweak here that I've made is that we're going to run our attacker script. As you can see, every 1 second or two, it's going to send me an update of how many devices I registered. Now I'm going to register my client. Now, before I do that, I want to make sure I open up my UID to show that this is indeed happening. Okay, so I'm going to register my client. I'm going to reload my UID.json. As you can see, Alice is registered. Now, the attacker here has also become a bit more smarter. Now he's going to run a variety of passwords, right? Not just one password. So let's see if he's able to do it. Now I'm going to start the UID impersonation attack. As you can see, he was able to brute force the password and the stream has been hijacked. Now I'm getting alerts here. I'm getting alerts. I'm going to reload my JSON file. As you can see, the attacker is the owner now. And the timestamps have there's a change in the timestamps also of when it was last seen. As you can see, I'm getting compromised UID alerts that this device user has been changed from Alice to attacker. Now, moving on to further defenses in the next clip. Now, coming to the hotkey defense, which was the most interesting part for me to implement in our system, our Kalay UID defense system. What is hotkey? Hotkey is basically an authentication mechanism that was available but was not implemented by many device manufacturers. Reasons being cost savings, convenience, inconsistent security practices between different device manufacturers. So this hotkey, this defense it provides cryptographic authentication basically between devices and the Kalay protocol. So it is a pre-shared key that's literally programmed into the IoT devices when it's created, like into the firmware, and it is used to sign and authenticate requests and prevent unauthorized UID takeovers. And so the problem now is many manufacturers they ship the devices with hotkey disabled, and by using default values, which gives room for attackers to do that UID impersonation. So what is that hotkey? Hotkey is basically the 256 cryptographic key generated during device manufacturing and stored securely in device firmware. Okay, and now we're gonna have a look at how this looks without the hotkey. How does our system look, right? And with hotkey, what is the difference in our system? So let's start our emulator. As you can see, emulator is working. JSON file, we don't have anyone registered yet. We're going to start our monitoring because we need to know whoever registers, whether it's Alice or an attacker. So registers devices 0. Now, what happens if let's before that we added one extra step over here. We're gonna check the status of our hotkey defense. What is the status? Currently, it's disabled, and it's telling us that our system is vulnerable. Right now, should Alice be able to register? Yes, Alice is able to register, and we have her in our system, in our JSON file. Now, should the attacker be able to do the UID impersonation? Let's see. And as you can see, yes, it was able to do it. And as you can see, the owner has been updated to attacker. We're getting an alert saying that the owner has been changed from Alice to attacker. Now let's implement the auth key defense and see how this changes. So we're gonna first clear our UID our JSON file. So let's reload because our JSON file has been cleared. Gonna stop our monitoring script. Gonna stop our server. Okay, now let's look at how the auth key defense is gonna work. So we're gonna start the server one more time. Okay, so server is ready. Auth key is disabled. Now what we're gonna do is start our enable our start our monitoring system first. Okay, monitoring system has been started. Registered devices are 0. We're gonna enable our security controller, which enabled our auth key defense. As you can see, this has been enabled. Auth key protection is enabled, and I'm getting a notification here also that it's been enabled. Now let's see if Alice is able to register. As you can see, yes, she's able to register. She now has an auth key, as you can see over here, and all her other information. Now, will the attacker be able to register? Let's have a look. And no, attacker is not able to register, even though he has the right password, Alice PW. He is not able to register due to not having the unique auth key that's generated. So attack failed. UID takeover it's unsuccessful. Gonna try again. Unsuccessful. Now will Alice say she wants to come back and re-register her device? Is she able to? Yes. And as you can see, the difference in timestamps show that she has signed in again. Okay, so yeah, so that's our defense. Next would be to implement a moving target defense to see how we can make this even more better. Now, coming to the moving target defense, it's not just a defense all by itself, it's an added protection to the auth key defense. So the moving target defense, what that does, it kind of randomizes UIDs, so the attacker doesn't know which ones are real and which ones are fake. Now, if they are able to get onto the real UIDs, they won't be able to pass because of the auth key defense. Now, say they are able to get get onto the fake UIDs, then we can exactly track them down and see which IPs they are coming from. So that is one of the reasons why this would be another great defense on top of the. Now let's see how this is going to work. So I'm going to first start our emulator. As you can see, emulators started. Now I'm going to start our monitoring, security monitoring. As you can see, 0 registered devices right now. Next step would be to see the status of our security control. As you can see, auth key is disabled right now. My MTD is disabled and DTLS, our encryption is disabled. So this means our system is vulnerable right now. So right now, what should happen is Alice should be able to register. As you can see, Alice is able to register. I'm also going to open up our UID.json so that we have our UID.json file. You can see Alice is registered right now. Now, will the attacker be able to register? Yes, as you can see, the attacker has been able to UID spoof, and if I reload this, now the attacker is the owner of the device. Now let's next step would be I'm going to reset this and clear and see how this would look with our multi-target defense and auth key defense. So I'm going to clear everything. Now let's start our emulator one more time. As you can see, emulator is working. Monitoring script is working too. Registered devices are 0. Okay, now let's make the status of our security. We're going to add auth key defense and multi-target defense. We're enabling moving target defense, and we're going to deploy the UID decoys, so fake UIDs. So this is enabled now. Now let's see if Alice is able to register. Yes, she's able to register with her auth key, and she is protected against the UID impersonation, which is going to happen. If I reload, she should be able to register. Yes. Now, will the attacker be able to register? As you can see, he's trying out all different sorts of UIDs that he's able to scan. He's attempting takeover of those UIDs, but he's not able to. As you can see, he was able to compromise 0. He was blocked by auth key 1 and trapped by multi-target defense, 5 of them, because of the fake UIDs that existed. The one real ID that he was able to do, the one real UID that he was able to actually get, he was not able to get through it due to the auth key protection. It was blocked due to the auth key protection. Now let's see if we can. I'm gonna try one more time. As you can see, again, he's not able to get through. We're getting system logs also saying that he's not able to do it. Thank you for viewing our demo. Again, future steps would be to see how we could integrate this with an actual camera instead of using an emulator, and see how we can implement these defenses basically. Thank you so much, and yeah.